After you've calculated your densities and your average densities for the Penny Lab, you are being asked to create a mathematical model or a graph of your data. After reading the instructions where it says where you're going to graph mass versus volume, mass on the y-axis, and volume on the x, you are going to be drawing a best fit line for the pre-1982 pennies and the post. So what that means is that we're going to be having two different lines. So I would like you to use and key two different colors. So for this practice lab, I have given you a key here where you can color in the lines of your choice. Now the first thing we do when we have a graph may seem to be the simplest of the tasks, but it's often the most forgotten, and it's a title. So if we title our graph, traditionally we'll do independent versus dependent. So in this case, it's mass versus volume of pennies. And it's nice to be specific so that people who read our graph know what we're talking about. We also need to tell our readers which axis represents which component. So mass goes on the y, so our y-axis is our vertical axis, so we're going to label it as mass with a unit, and volume is on the x, which is our horizontal axis. We're going to have vertical, not vertical, silly, volume in milliliters. The next thing we need is a scale. So if I look at my data, now this is my pretend data, this may or may not match yours. When I had 5 pennies, it had a mass of 15.42 grams and a processed or calculated volume of 1.5 milliliters. And I look at my largest number when I had 25 pennies, and it was 82.90 grams with a processed or calculated volume of 9.5 milliliters. According to my graph, my grid has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 major grid lines. And because my mass goes up to 82.9, it might be best to label each major grid line by tens. This keeps our minor grid lines, we can keep track of them a little bit better. So with my volumes though, it looks like my highest volume is 9.5, and I still have 10 major grid lines. So that means I can scale my graph by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Sorry about that. In order to graph my data, I have to look at my mass and my volume as my x and y coordinates. So my volume is my x and my mass is my y. So for my first data point, I'm going to go up to 15 and then over by 1.5. For my second data point, I'm going to go up to about 43, which is about right here, and over to 1, 2, 3, 4, 5. And my last one, my mass is about 83, so I'm going to go up to about 83, and then over to 9.5, which would be about here. Now because I want a best fit line, that means I do not connect the dots, but instead I'm going to take my ruler and I'm going to line my ruler up as best I can with my points, and there's my best fit line. So because the red line is representing my pre-1982 pennies, I'm going to color this box in as red. So now I get to complete this process one more time, but for my post-1982 pennies, and I'm going to be using a different color. At the bottom of this page, you're going to see that we'll be calculating slope. So just to make things easier for ourselves, I've copied my data points from my graph, which is the same data points that I recorded in class. So you'll be doing the post-1982 portions on your own, but I would love to show you how to do the pre-1982 portions here in this video. Now back in pre-algebra, you guys learned about slope, where the change in the y-axis over the change in the x-axis is also known as rise over run. And we find the rise by taking the difference or subtracting the difference between the two y values and the difference between the two x values. To be really honest, it doesn't matter which points we pick. We just have to pick two of them. So just for fidelity's sake, I'm going to choose my first and my last one, remembering that volume is my x and mass is my y, based on the graph before. So volume's on my x and mass is on the y-axis. So I'm going to choose the first and last points. So remember that coordinates are given in an xy fashion. It's going to be 1.5 and 1542. And my second point is 9.5 and 82.90. So with my equation for slope, which is given to me right here, slope is also known as m. So the slope of a line m is equal to my second y-coordinate minus my first y-coordinate over my second x-coordinate minus my first x-coordinate. So because this is coming first in my graph going from left to right, this is point number 1 and this is point number 2. So I'm going to be taking my y2 coordinate, which is 82.90, and I'm going to subtract from my y1, which is 15.42. Then I'm going to divide it by my x2 coordinate, which is 9.5, minus my x1 coordinate, which is 1.5. So I'm going to take my calculator, and I'm going to do the subtraction first. So 82.9 minus 15.42. So our top number is 67.48. And then we're going to do the bottom part. And 9.5 minus 1.5 is equal to 8. So now we get to simplify this even farther. So 67.48 divided by 8 is equal to 8.435. So 8.4, and let's round to 2 decimal places because that's what I've got going on here. 8.44, I think I need a unit. So the rise was the mass, so the y-axis was mass, and that's in grams. And that's over volume, which was in milliliters. So this is grams per milliliter. So if you need any help with graphing or with slope, please feel free to text me on Remind or email me.